This question is related to calculating Ksp from solubility. Question says, solid silver chromate is added to pure water at 25 degrees centigrade and some of the solid remains undissolved. The mixture is stirred for several days to ensure that equilibrium is achieved between undissolved Ag2CrO4 and solution. Analysis of equilibrium solution shows that its silver ion concentration is 1.3 into 10 to the power minus 4 m. Assuming that Ag2CrO4 dissociates completely in the water and there are no other important equilibria involving Ag plus or CrO4 2 minus ion in the solution. Calculate Ksp for this compound. So we have to calculate Ksp value for Ag2CrO4, and Ag2CrO4 is acting as a solid. When you add Ag2CrO4 in water, what will happen? If you add Ag2CrO4 solid into the water, so this is water solution, and this is solid of Ag2CrO4. Now some of the Ag2CrO molecule will go into the water that will dissolve. This process is called dissolution. So if I have Ag2CrO4 solid and some of the molecule go into water, and this process is called dissolution. Ag2CrO4 aqueous, now it is dissolved in water. This process is called dissolution. Now the dissolved Ag2CrO4 can dissociate and it can give 2Ag plus CrO4 2 minus, and this process is called dissociation or ionization. So this is dissociation. Now question says, assuming that Ag2CrO4 dissociates completely in water, that is whatever Ag2CrO4 is dissolved gets dissociated. So we have all dissolved Ag2CrO4 gets dissociated. If this is the case, then we can add two equilibria. So first equilibria we have Ag2CrO4, this is solid and this dissolves in water, Ag2CrO4 aqueous, and this gets dissociated. This is aqueous, this is also aqueous. Now all the dissolved Ag2CrO4 gets dissociated, so we can add these two equilibria. So if I add these two, this cancels, so we will have a overall reaction, and that is dissociation of Ag2CrO4 solid that is 2Ag plus aqueous plus CrO4 2 minus aqueous. Now if 1 mole of Ag2CrO4 dissociate, this gives 2 mole of Ag plus. So let us say Ag2CrO4 dissociates x mole. So it will form 2x mole of Ag plus and x mole of CrO4 2 minus. Concentration of Ag plus is given, that is 1.3 into 10 to the power minus 4. That is the value of 2x, because concentration of Ag plus is 2x. So we can equate this. 2x is equals to 1.3 into 10 to the power minus 4. So x is 0.65 into 10 to the power minus 4. Now we can calculate Ksp value for this reaction. So for this reaction, Ksp, this is equals to concentration of CrO4 2 minus into concentration of Ag2 plus raised to the power 2. So we have Ksp is equals to 4x cube. So this is 4x square into x, that is 4x cube. Now we can plug the value of x. So Kxp is 4x cube. X is given 0.65 into 10 to the power minus 4 raised to the power 3. So let us do this calculation. So 4 into 0.65 into 10 raised to the power minus 4. And this raised to the power 3. So this is 1.09 into 10 to the power minus 12. So this value is 1.09 into 10 to the power minus 12. So Ksp for Ag2CrO4 that is solid insoluble salt, and this is equals to 1.09 into 10 to the power minus 12. Ksp will have no unit, so Ksp is a unitless thing. All equilibrium constants are unitless. Ksp is unitless. So you see, what we have to do is, in this kind of problem, we will be given solubility, that is concentration of one of the ion, and then we can calculate the solubility product. Important point, this solution process of dissolution and process of dissociation can be added, because 100% dissolved gets dissociated.